Thanks for joining us for this Vulcan webinar. My name is Catherine Vosper and I am the Maptek Mine Planning Sales Manager based in our Brisbane office. Today, Maptek Technical Sales Manager, Mine Planning Solutions, Steve Sullivan, starts our 2019 webinar program with a review of features in Vulcan that will assist the mine geologist in making their job easier. Vulcan has a wide range of tools, and because of that depth of functionality, there are some tools that may be not as well understood as they could be. In today's webinar, you will learn how to integrate a broad range of different data when building your geological models. If you have any questions during the webinar, you can enter them into the questions panel on the GoToWebinar interface, and we will answer as many as we can, time permitting, at the end of the session.
Thank you, Catherine, for the introduction, and welcome to Vulcan viewers around the world. In my role at Maptek, I travel to many different locations, helping geologists use Vulcan software. With the introduction of new technology and improved sensors, there's an increasingly wide range of geological information that can be used to aid interpretations and build your geological model. For new Vulcan users, it can be daunting after completing an introductory course to master all these available techniques. And in the next 20 minutes, I'm going to review some of the functionality that is available, some that existed for many years, and combine that with some new functionality included in the latest Vulcan versions. Now, the best way to understand some of these features is for me to jump into the hot seat and go live.
Anyone who's done the Vulcan introductory course over the last probably 20 years is familiar with this data. So we've got a topography here, got a few drill holes, and in this case we've also got some underground working. So this is just a simple data set I'm going to use today to demonstrate some of the capabilities that are available in the Vulcan geological modules. So we'll just go back to plan view. Most of us are still, even in this day, happy to look at sections just to review what's happening. Even though we have nice complex 3D models, we often like to going back to the 2D just to investigate what's going on. So here's a simple cross section, a few different drill holes. This one's not, it's coming in off the plane from another outside the viewing plane. And we have here some values of interest. So just to show you what they are, this is a drill scheme looking at copper, and pop those down the corner there for you to think of. So here, really the brighter colours are the higher grade. So on a conventional, if we're doing some type of polygonal based interpretation, or if we're just looking at our geology, we can use some of the existing tools to label those drill holes. And just click on the hole there, and here we can have something on the right hand side, on the left hand side. I've made one previously, so I can just load that and it records my settings. So I've got copper on the right and gold here on the left. So you can configure how many decimal places and where you want it to appear on the screen. So that's a very simple matter there of displaying that, and again I can just click on other holes, or I can do the entire database depending on what I want to see. But for this case, just want to show that, there we are. We've got some obviously quite good grades in places there. So that's pretty well known. Everyone should be familiar with that. So maybe not everyone's familiar with another way of looking at geological data down the hole, and that's if we look at what's called the downhole geophysics menu. Now, downhole geophysics menu doesn't have to be geophysics. It can be any numeric field, and we can display that numeric field, whether it be copper, gold, ash, whatever you want. We can display that down the hole as either a bar graph or a continuous trace. So I'll just load this up. Again, we're going to connect to the database that we've got here open. And then similarly to the other one, you can say what you want to display, copper and gold. And you can see now that on top of the labels, I've got now a bar graph here, and on this side I've chosen a continuous trace, just to show the two different representations you can use. And sometimes that can make it easier to do your picks if you're doing some type of manual digitization. You've got more information than just either colors down the trace or some labels. Okay, so if I want to do some interpretation here now, I'll just pick up a polygon, enter a layer, just this. And I can start using my icons down here, first of all down here, and then I can maybe snap to a drill hole. I can zoom in and snap to drill holes if I want to pick different points, or I could use a range of the other icons. The draw by hand here, and that allows me to move continuously and to zoom in and out as I go. If I make a mistake at any time, I can use the backspace key, and that'll go back. So if I didn't like what I was doing there, just hit backspace a couple of times and just continue on. So you're not here to watch me digitize, so I'll just close that off. So that's just a simple polygon that I've done just with the polygon icon there. If I click on there and look in the properties editor, it hasn't got any particularly relevant properties. It's just got the default options there. So to improve that, and something that's been in Vulcan for many, many years, and as I travel around sites, not everyone's using it, so that's why it's going to be shown here, is the use of features. So we have a feature editor here, feature editor, and that allows you to set up a whole lot of different structures within a particular geological characteristics. So in my case here, I've already got set up a couple. I've set up a vein feature, and I've forced it to go a particular color, and I can then apply different groupings and values and all sorts of different attributes. So instead of just having a very bland default setting here, I can attribute that, and then allows me to have some more selectivity when I'm working with design objects inside Vulcan. So to demonstrate that, as I say, you can use the icon here, or it's also available under the Design Create menu, under the features. I can pick off a list, and there's some people out there who've got over 200 of these, so you can get some very good structures. Good for fly-in, fly-out operations. We got a lot of people who only have a very small handover between different shifts. So that now when I start drawing, let's go back here, and when I draw instantly, you can see that it's already changing. The color is no longer the default white. It is the color that I've defined and predefined in my feature. And it doesn't matter whether I draw it or my colleague or someone who's on night shift, it's always going to be the same because that's the way the feature was set up. And this file can be shared on your corporate standard directory, so everyone on your network or even your organization around the world can be sharing the same characteristics, so that every time you digitize something, everyone in this case knows that that color and that structure is a vein, as shown here in the feature. Okay, so features are very useful. Okay, so we'll just delete that object, go back into our plan view now, and just remove our geophysical traces. Okay, and I'll just remove our topography as well. So that's using a couple of different options there to demonstrate some capabilities within your within your drill holes themselves, just conventional drill holes. Now I've got a couple of other drill holes here. Now I've at the moment saved them in separate databases. That doesn't need to be the case. They can be stored in the same database. And I'll just load that. I've only got one hole here just as an example. And you'll see here, and I've deliberately made it a different weight so that you can see the hole, and maybe just make those invisible for the moment. So you've got a drill hole there, and in this particular hole, what I can do is I can go up to our Analyze menu. We have an external data, and I've already set up the ability to click on the hole, and then display where I've clicked the drill tray associated with that drill hole. So I've got a whole lot of different core tray photos, as you probably got, and you can go and have a look at those so that when you're doing your interpretation, when you're reviewing data inside Vulcan, you don't necessarily just have to rely on colors or labels or histograms and traces. You can go back and see the rocks themselves, and we're looking for veins. So here's a nice vein right here and right here. You can see the depth in the tray, and that may help you with your interpretation. So don't leave your core tray information behind. It's very valuable, and you should be using it. So if I click further up the hole, you'll see there's the next tray up the hole. If I double click twice, I get two, so away you go. So you can get access to all that drill core information inside your 3D environment. Okay, and there's one other different type of hole that is useful. Again, I've got this separate database. It doesn't have to be. It could be embedded in your drilling database. And this one here is a downhole televiewer. So I now bring in the photography here, and you'll see this hole here now. You'll see that it has got photography associated with it. And then this hole here has come from a downhole televiewer. They've been around for, again, a couple of decades. Quite expensive in the early days. They're used mostly for geotech, but they're becoming more and more common for especially complex geological ore bodies in the underground, trying to understand what's going on. Okay, so just move around this hole a little bit, and eventually I'll find some structures. See there, there's definitely some structures, whether that be bedding. Looks like some bedding to me. And even though, yep, I've got that in 3D. The width of this hole is the true width of the hole. The acoustic televiewer do have calipers down the hole, and what we're seeing there is exactly. So if that's NQ2, it might be 50 mil, or it might be HQ, and you're getting the real hole width displayed on site. Now I've got a structure here, so what I can do is I can just go straight through to the geotech menu and start digitizing that structure. So what I want, one point there, and important, just click on this one here to grab that point. So I say pick that point there, pick that one there, come around, and where's another point on that structure, say about here on that contact. Give it a name, I'll give it 100. Couldn't find that one. Append that to the database, and what you'll see straight away is you'll see that it's drawing a structure. See that structure there? And it's done a pretty good job of putting that orientation of that structure down dip of what I've done, where I interpreted. So as well as drawing in 3D, I can also classify that. What type of structure is that? So I've got a range of preset ones that I've set up in my geotech database. So I'm going to call this one a bedding structure. I can also put a whole lot of information here as to the hole name. I don't really need the alpha and beta angles because I've measured it directly on the screen because it's all oriented. The roughness, well, that looks pretty rough to me, so roughness, we'll give it number 2. Whether there's any infill, well, that's more for veining, not really. Thickness, I could scale it and measure the thickness if I wanted to. You can see there I could also move it around. When I've finished, I can just save that point. And I think I've just right-clicked and did the do that one again. Just right-clicked at the wrong time and lost my structure. So I'll just roll that around, show you how easy it is to get back again. And call that one 101, just to, yeah, that's fine. And again, I'll call that one bedding. And I'll call it 21 this time. Roughness, yeah, roughness number 2, etc., etc. So whatever you fill in here will be stored in the geotech database. And once you've committed to that, you can see the symbol comes up, and you can see how it's nicely oriented as per that. So you can take oriented core measurements from the televiewer. You can take it from mapping underground. You can take it from surface mapping, whatever it is, and you can digitize those. And just to show you that that does exist in the database now. Using Vulcan 11, remember that the ISIS database now is available through the tools menu. And we were looking at the geotech database here. So if I go through here, you'll see that there's a whole lot of readings here, and the one that I called with 0.2 was that last one. So that's the record that we've entered from there. And that can then be used into stereo nets, rose diagrams, and integrated into the whole geological database, all given to the geotech engineers for use in their work. Okay, so that shows a range of different other attributes you can apply to help you interpret in 3D. So we've got the acoustic televiewer, and we've got those core photos that you can click on and link them to your 3D hole. Okay, so let's just now move on to some mapping data, and I am showing this in an underground scenario. Doesn't mean that everything that I've shown so far couldn't apply to open cut, just that I happen to have some underground data, so that's why I'm using that here today. Okay, so if we just pop our underground development back on, there we are. So we've got some underground development as we had before. We've removed everything else. And underground mapping, now I've got 4 cuts, a few meters apart. Underground development there, and just show you a couple of different ways of incorporating that into your modelling process. So I've got, as I say, 4 there in Vulcan. Well, you haven't probably got it yet, but in the new releases of Vulcan, there's a new image viewer, and this allows you to open up images. So I've got a couple of images here. So you can load them up inside the Maptek workbench, and here we're starting off with some very simple underground quick sketch. And you've got in there. You've only got a couple of minutes before the dreaded shot creditor comes in and blasts your geology and covers it up for good. So if someone's come in and just done a quick sketch, there's some volcanic contact there, bit of sandstone, nice bit of veining there. Next, the veining is getting a bit thicker, etc. And then a couple of shots again. You hadn't had much time. Just gone to a quick digital photo. Again, we've got a contact there and some type of vein, and finally another contact, and it looks like a lot more folding in there. So this little image viewer, which you'll see pop up in the Maptek workbench in coming versions, is just another handy little addition to have stuff embedded inside the workbench rather than you having to go to external third-party applications to grab some of this functionality. Okay, what do they look like in our 3D view where we're doing our work? So I can just, I've already registered those. That's part of the introduction course to Vulcan. If you don't know how to do that, just give your local Maptek office a call and they'll help you on the support line. So there they are, registered in space. Again, quite simple. They're in that drive as we showed earlier. So got the simple mapping, got a couple of digital photos, and then I've got a final one which I've just hidden in view for the moment, and that's here. So really we're going through, I guess, different maturities of mapping. Early days and still sometimes handheld mapping, digital photography, and the last one here we've got permission from one of our customers to use one of their images and three-dimensional arrays from their latest Maptek SR3 underground mapping scanner. So this is an image scanner that takes not only the geometry, but also a very detailed geology photo. I think in this case it was about 130 megapixel image, and the point spacing on the geometry here is between 1 and 3 millimeters, so extremely accurate. And they too can be used, as you can see, to just digitize in 3D and incorporate that data. So again, we've got 3 levels of information, from the fairly basic, a little bit better, to you can't really get much better than that technology there. What we want to do here is digitize through these. I know there's lots of automated modeling tools these days, but I find when you're really in the close detail and you've got this level of information, some of the traditional tools work just as good, if not better, than some of the automated tools. So now I showed you how to digitize before with features. So like all good chefs, here's one I prepared earlier. We've got here on each of those different types, we've got the volcanic structures and then the veining. And you'll see the veining is getting a little bit more complex as we go through. So, but it shouldn't provide too many challenges to link that up into a nice three-dimensional model. Okay, so we'll have a go at that. The model solid create. Fairly conventional tool. Again, you learn this in your intro course, so this should be revision for most people. Select a color and just join the two up, and I can just continue on. And there's all sorts of fancy tools there to split and do bifurcations and all sorts of other things. So that one there, quite simple. I could then just go through there and save that off. And now what we'll call demo volcanic. That's done. It's overwritten my previous one. That's fine. Similarly with the next one, right click just to get your previous history, and I can pick these veins. And what's the colour for the veins? Something a bit paler. So that was quite simple. That's one shape. This is still one shape, but it's starting to get a bit more complex, going from just a simple lozenge to, I guess, say something that looks like a pair of pants. And let's join that up, and then it's even more complex when you come through to the laser scanned face. You can see that, and that's still, look, spin that around, manipulate that easily. That's joined that up. That's done a nice job. Now, I've deliberately kept them open because I know that in another shift's time, I'm going to have another one of these and another one, and they just build on. And then when the development has finished, I then generally close them off, get volumes, and if need be, go and interpret tons and grade, etc. against your block model. So, but we'll just save that one off for the moment. That's the vein. And so that's using different types of data, registered in 3D and building your solid models. And just one little final trick. It came out probably 2 or 3 versions ago, but just so that people are aware of. You've got a few different shapes there, and sometimes your shapes can be very complex between them, and sometimes they need a little bit of assistance. So there is a tool to help you there. If we go to a polygon edit menu, you'll see a thing called Morph. And what that allows you to do is select two polygons, one on each end. So I'll just pick that one there and this one there. Right click on that, and it allows you to do some intermediate shapes between that. So in this case, I'll just choose 4, and you can see how it's now done 4 shapes which are transitional between the 2 end shapes. And I can then save those shapes, or I can reject them and try again. Maybe I want 10, maybe I want 3. So if I retain those, they now sit as into your design database, and you're able to edit those and change them, and maybe just guide the shapes and the way you want the model to go from this shape to another shape. So there's a bit of user control there. So have a look at that one. That was the design polygon edit Morph. And I think, Catherine, that's about all I want to show for this webinar. So back over to you for if there's any questions.
Thanks, Steve. Before we move on to questions, can you let us know what Vulcan modules users need to access the tools you've shown today?
Okay. Today, all I've shown is the Vulcan geomodeler. So that's the base module that most geologists would use on a mine site. So Vulcan geomodeler, you can add other things like the base geostatistics and simulation, etc. That's not necessarily required. This is just base geomodeler. The only thing was a little bit different. Would require the geotech module was when I had the oriented drill core and I was rotating it around, and then I digitized that structure. Digitizing that structure into the geotech database requires that geotech module. So there's a whole lot of other functionality that's relevant in terms of stereo-nets, rows diagrams, tadpole plots, etc. in that, which I haven't expanded upon. Could be a topic for another webinar. But yeah, just the Vulcan geomodeler plus the geotech toolbox just for that one item.
Okay, so looking at the questions that have come through, let's start with this one. How did you link up the core tray photographs with the downhole trace on screen?
Okay, and I guess I did show a lot of the features without showing the background. That's a good question. As you see on the screen at the moment, there's an image from the drill hole, and you can see the syntax here. I've got a drill hole name, I've then got an underscore, I've got the start of the core interval, and I've got the end depth. So that's the syntax. You can use a variety of different syntaxes. We support maybe 15 or 20 different naming conventions, but that naming convention allows Vulcan to take the query from 3D, then query the database in the drill hole database, and link that together, and then populate the view of the image viewer. So yes, it's all in the naming convention there. And again, if you need assistance with that, just contact your local Maptek office, and we can talk you through that.
Thanks, Steve. So another question I can see, what type of colour legend is used with the downhole geophysics menus?
Okay, well, I might just cut out of the PowerPoint and just go live here again. The downhole geophysics, we have many different colour legends here, all controlled by the legend editor. And the one that I used here, which you have to use, is the pattern legend. So you probably haven't seen or used that before. So again, I've got a color distribution, so I can show you an attribute such as copper. I can then pattern fill, and this in this particular case is a blank is no color. Oh, sorry, no pattern, and this one here is in solid pattern. So I set up this this pattern scheme here under the pattern, and then just save that and use that. So you note that I've got copper color schemes for the pattern. I've got copper color schemes for the drilling. I could have some for the block modeling. I could have some for channel sampling for underground, and I could also have them for sampling. So there's many places that you can use and control inside Vulcan to get the colouring and the this display as per your requirements.
Okay, I think that's all we've got time for today. Thanks again, Steve, for this features showcase. For the resource geologist, there is a second session in coming weeks covering additional long-forgotten functionality relevant to grade estimation processes. Customers with current software maintenance can download the latest version of Vulcan from users.maptek.com. So as you can see, Vulcan 11.0.2 is available now. So of course, if you have any questions about Vulcan, please contact us. You can find all the relevant contact details on our website. If you'd like to view this webinar again or share this with your colleagues, it is available online via our website, maptek.com. And while you're there, I encourage you to catch up on other webinars covering a whole range of topics. So coming up in 2019, you can expect a variety of webinars covering the Maptek solutions, and we welcome webinar topic requests. Thanks again for watching.